Yes, let us consider these questions that we have here on both HCF and LCM. So, mind you, don't think that every time question asks you to find HCF, it must ask you to find LCM too. No, sometimes question can be separated. So a question can just be for HCF and then it can just be for LCM. So I'm just teaching it together just for you to see the relationship. You need to master HCF separately and master LCM separately. But most of the questions that I give are for you to see the relationship between them. But questions are always separate most of the time. Now, I want to quickly give these questions. I will solve them. This is the last thing that I will do on HCF and LCM. Now, so there are sometimes you don't even need to solve question. So with simple idea, with simple fact, you can get the answer of HCF and LCM very smartly. Why sometimes you will need to solve. So now look at this number 1. We have find the HCF and LCM of number 1A, 5 and 6, 1B, 4 and 8. Let me add one more. Let's say C. Let's say 48 and 90. Okay, so just to show you all possibility, these are the different ways that questions of HCF and LCM can come. Now for number 1A and 1B, I bet you don't even need to solve. So, and even if you solve, you will get the same answer. So let's go for 1A first. Solution. So 1A is 5 and 6. So if you notice both 5 and 6, there is no number that can divide both of them together. So no common number that can divide both of them except 1. So it is only 1 that can divide both of them. What does that tell us? It means both of them are co-prime. Mind you, please, people always get this wrong. They always confuse the concept of co-prime and relative and prime. Prime number is different from when they say two numbers are co-prime. Look at the word co. Co means two. It involves two or more. So co, that is cooperation. When you cooperate, it means you are more than just only you. So you are more than you are many that do that thing. So now, let me now say co-prime. That is, both of them together like that, they are prime. But if you pick individual number, they may not be prime. So for example now, 5 is prime. That one is sure. But 6 is not prime. 6 is not prime. But bringing the two together, their HCF is 1. The only factor that is common between them is 1. So that means they are both co-prime. Sometimes we call it relatively prime. If you don't want to say co-prime, you say relatively. Relatively prime. So if it happens like this, no matter what you try to do, the HCF in this situation, HCF will be 1. Since there is no number that can divide it, even if you draw table, put 5 here and put 6. So there is nothing, no number that can divide both of them. There's only 1. So 1 in 5, 5. 1 in 6, 6. You still be getting the same result. If you put 1 again, you still get 5 and 6. So no need of wasting time trying to find HCF in this case. So HCF will always be 1. And then the LCM too. Since the HCF is 1, anytime HCF is 1, LCM will just be multiply the two numbers together. That's 5 times 6. That will give you 30. So you don't even need to start drawing table. So Once you notice that HCF is 1, then LCM will just be the product of the two numbers. Just multiply them together. So 5 times 6, that will give me 30. So these are simple tips that will help you in calculation. So let's see the second question. Let's see 1B. Question 1B, 4 and 8. Now, in this case too, you even need to solve, you need to calculate. So look at 4 and look at 8. You observe that 4 can perfectly divide 8. 4 can perfectly divide 8, because if you do 8 divided by 4, that will give me 2. There is no remainder. So if it happens like this, that the smaller number can divide the bigger number, don't worry yourself. HCF will just be the smaller number, 4. And the LCM will just be the bigger number, which is 8. So no need of stressing yourself in this case. Even if you draw the table and try to solve, this is what you will still get for the HCF, and this is what you will still get for the LCM. So I'm giving you these tips to help you do some simple calculation in your head without solving. So that is how it goes. Once you notice that the smaller number can divide the bigger number. For example, now also if you have 16 and 32, of course 16 can divide 32. So this HCF will be 16 and the LCM will be 32. So similarly, if you have 2 and 10, so 2 can divide 10 perfectly. So that means HCF will be 2 and LCM will be 10. So you can have different cases of this one also. Now, let's go for number 3. Let's go for number 1C. 1C. So we have 48 and 90. Now, does 48 satisfy the first rule? That is, first rule that say if both of them does not have anything in common, if they don't have anything in common, so it doesn't satisfy the first rule. So because 48 can be divided by 3, and this one too can be divided by 3. So there are so many numbers that can divide both of them together. So many numbers. So it does not satisfy the first rule. What about the second fact? Can 48 perfectly divide 90? And that's not. So it cannot. So in this case, you don't have any choice than to draw your table and solve. So let's go for the HCF first. I will do 48. I will do 90. You can use any of the methods that are taught before. So you can use the prime factorization method. You can use the Venn diagram method. Anyone. Now, so you first of all, like I always say, you first of all choose a number that can divide both of them. No matter how small it is, choose the smallest number that can divide both. So that's how you do it to make it easy for you. So 2 can divide both of them. Always try 2 first. 2 can divide. 2 in 48, that will give me 24. 2 in 90, that will give me 45. Now at this point, 2 can no longer work, but 3 can work now. So 3 in 24, that will give me 8. 3 in 45, that will give me 15. That will give me 15. So now at this point, you will observe that 8 and 15, they are also co-prime now. 8 and 15 are co-prime. So they are both 8 and 15 have taken us back to this fact, to this fact number 1. So at this point, this is where our HCF will end, because there is no other number apart from 1 that will work in this situation. So that means HCF in this case will be 2 times 3 and HCF will be 6. But as for LCM, you still need to go further. LCM does not stop there. So you put 48 here and you put 90. So I just want to redo it so that you see. you can start your LCM the same way you started the HCF. So always choose something that can divide both first. So 2 in 48, that will give me 24. 3 in 90, that's 45. 3 can go now. 3 in 24, that will be 8. 3 in 45, that will be 15. So now, since nothing else can divide 8 and 15, I will just bring the 8 first or bring the 15 first. So let me bring 8. This will be 1. This will still remain 15 because 8 cannot be divided by 15 cannot be divided by 8 perfectly. Next, so since this one has become 1, I will just bring 15. So this will be 1 and 1. So you must break LCM down till you get 1 and 1 at the bottom. So my LCM will just be what? 2 times 3 times 8 times 15. So I'm just going to multiply all of these together. So what? 2 times 3 is 6. And 6 times 8, that is 48. Then 48 times 15. You have to do that. 48 times 15. So I can simply do 48 times 10 plus 5. So in a simple way, I can just do 48. 48 times 10, that will give me 480 plus 48 times 5. How do we do 48 times 5? Just divide it by 2. That will be 24. Then add 0. That will be 240. So you add together 480 plus 240. 0. 8 plus 4, that will give me 12. Carry 1. That will give me 720. So the answer is 720. So you can see that HCF and LCM can be so simple sometimes. So that is how, these are the 3 different cases of HCF that you can have. So sometimes you don't need to solve. By just looking at the question, you will know the answer. Now, however, I still have 2 more questions. These ones are word problems. Word problems. So, for word problems, you really need to carefully observe the question and see what the question is asking for. So, solution. Let me give you some tips that will help you first when you are talking about word problem. When you hear the word greatest, find the greatest possible something. So they are talking about HCF like that. So, and if they ask what is the least, if you hear the word least, just know that they are talking about LCM. Okay. So now look at this question 2. You will not hear the word greatest or least there, but you have to think and see which one are they talking about. So when you see this type of thing, you know that it is LCM that you are talking about. The question says 2 bells ring every 12 minutes and 18 minutes. 12 minutes and 18 minutes. 2 bells. So the first one rings 12 minutes, every 12 minutes, and the second one rings every 18 minutes, respectively. So if they ring together at 9 a.m., they ring together at 9 a.m. So after how many minutes will they ring together again? So they want them to ring together. They are finding the common time that both of them will ring together. In this case, so the common time must increase, must be bigger than even the both of them. So the common time must be bigger than both of them. So that has to be the LCM of both 12 and 18. So we just find the LCM of 12 minutes and 18 minutes. So I'm going to draw my table because this one does not belong to category 1 or category 2. It doesn't belong to case 1 and case 2. This is case 3 question. So I have 12 and I will have 18. Of course, I can choose every small number first. 2 here, 6, 2 here, 9. 2 again, this will give me 3. Oh, 2 cannot work for both of them. So I want to choose something that will work for both first. Of course, we can still use 2 that work on this, but let's choose something that will work on both first. 3 can work. This will give me 2. This will give me 3. So now, nothing more than to bring the 2 number. 2 here, 1, here, 3. Now, 3 now, 1 and 1. Therefore, LCM will be equal to 2 times 3 times 2 times 3. So first of all, 2 times 3 is 6, and 2 times 3 again is 6. So the answer will be 6 times 6, which will be 36 minutes. So after 36 minutes, that's when they will ring together. So it means, so if they ring together by 9 a.m., that means they will ring together at 9:36 a.m. That's when they will ring together again. Okay, let's see the second question, which is question 2. Sorry, I have to manage my board because I'm using a smaller board. So that's why I'm cleaning all the time. So please, if you have not subscribed to this channel, kindly click the subscribe button. Subscription is free. It's free, completely free. Please. So let's continue. Question 3. So the question says, a teacher has 48 pencils and 60 erasers. She wants to divide them into the largest possible number of identical groups with no item left over. How many groups can she make? This is very interesting. You see, when you hear the word greatest or any synonym of greatest, just know that they are finding HCF. So there is no greatest here, but there is largest. So largest also means greatest. So in this case, we are finding the HCF. So I'll just do the HCF of 48 and 60. 48 and 60. So this one does not belong to the first case, nor the second case, but it belongs to the third case because there are common numbers that can divide 48 and 60. So I have to draw my table. So this is 48 and this is 60. So let's bring something that can work on both first. 2 can go. This will be 24. This will be 30. 2 can still go. This will be 12. And this will be 15. 2 can no longer work, but 3 can work now. 3 in this will give me 4, and this will give me 5. So at this point, these two numbers are co-prime. So there is no other number except one that can work. Therefore, I will conclude that the HCF is equal to 2 times 2 times 3. So 2 times 2 is 4, 4 times 3 is 12. So that means it must select 12 groups. So in each group, it must have 12 items. So it can make 12 groups from what it has, from the information it has. So thank you. You can see that word problems can also lead to HCF and LCM. Get familiar with questions and do more questions on your own. You will see more questions in the textbook. You can get the Essential Mathematics WAP B. So you can get that. That's the textbook that is mostly used in most secondary school nowadays. So, and it will help you to understand this topic more and to get more questions done. Thank you. God bless you.